Good morning, mathematicians. We are looking at our Tuesday column of week 11, starting off with this question, which asks us to shade 1/2 of 1/4 of the below square. So if I get started with that, first of all, I notice it needs to be 1/2 of what? Well, it's 1/2 of 1/4. So I'm going to go ahead and divide this up into quarters. So here is 1/4. And how much of that quarter do I want to capture? I want to capture 1/2 of this. So I'm going to go ahead and I'm going to partition that off. And I'm going to shade it to show that this is 1/2 of 1/4. Now, if you want to, you can kind of go ahead and do this to show you that you have completed that and that it for sure is that 1/2. But clearly we can see we have followed those directions. Now let's go down and we're moving into volume for every other question of today. This says, what is the volume of the below figure? Notice we are not looking at cubes, we are looking at a prism with listed dimensions. So I'm going to be multiplying those together. So I can see that I have 20 times 3 times 3, right? I have its length, its width, and its height. I'm going to combine my 3 times 3 together so that I have 20 times 9 because here I can use my basic factor zero trick. 9 times 2 is 18, and then I have 1 0 outside that basic fact. So my answer is 180 what? Well, it is 180 inches cubed. And I'm going to go ahead and write that answer right here. I've got 180 inches cubed. Now I'm going to be looking at my next question. My next question is, what is the volume of the below figure? I have an irregular shape here. I see a prism on the bottom and a much larger prism on top. Let's go ahead and find the volume of our smaller prism. And let's find the volume of our larger prism, and then we'll join those two together. I'm going to go ahead and call this prism A on the bottom and this prism B on top, and that way I can be clear about where I'm finding those dimensions. So this has a length of 5, this has a width of 2, and the height is not listed. But I know that this entire prism between both of them has a height of 4 inches. But I know that 2 of those inches are accounted for in prism 2. So that tells me what I need to know. This has a height of 2 inches. So this is going to be times 2. Well, 5 times 2 times 2 gives me a volume of 20 inches cubed for prism A. Now let's take a look at prism B. Prism B, we have 13 times, remember we already know it has a height of 2. We talked about that. What was the width? Well, the width of our bottom prism was 2 inches. So we are going to assume that this also has a width of 2 inches as well. It looks to be 2 inches, plus it's not labeled. There's no way to figure it being different, so we can assume that it is the same. I see that I've got 13 times 2, which is 26. And then I'm going to be taking 26 times 2, which gives me an answer of 54. Now let's join these together. Actually, this gives me not 54, 52. Now we've got it. All right, we have 52 what? Well, it's 52 inches cubed. 20 inches plus 52 inches. To combine those two volumes together tells me that the overall volume of this shape is 72 inches cubed. Now we're going to come down. We notice a cuboid. It says that we must complete the cuboid and then we'll determine its overall volume. Whenever you're given something like this, notice you have all of the lines that you need to see exactly where to go. And I always tell my students to look at one face at a time and to complete the rows and the columns. So I'm going to go ahead and complete like the columns here. This one has already got a column, but I need another column that goes from here to here. Now I'm going to look and complete the rows on this column or on this face. I see this top one is already done, so I'm going to get started with my second. The third one is already done, but I need to do the fourth, and then I can continue and see Now this face is fully completed, and it tells me exactly where, if I continue that work from the top, where it needs to go so that now it's a fully completed cuboid. Now we're going to look at the dimensions and we can go ahead and find the volume. This one, we can find the volume by actually counting the cubes because how many layers does it have? It has one layer. So I notice that this length right here has 1, 2, 3, 4, 5, 6. There are 6 cubes in this first row, right? Let's double check and count them again. 1, 2, 3, 4, 5, 6. Well, if there are 6 cubes here, then how many cubes are there going to be here? 6 more. So that gives me a total of 12. And 6 more, which gives me a total of 18. That tells me what I need to know that there are 18 cubic units in this particular cuboid. All right, the last one does not have a prism drawn for us. So instead, we're just using the information to answer the question. This says, what is the volume of a square whose faces have an area of 36 cubic centimeters? Actually, 36 square centimeters, because we're thinking about area. Well, a key detail that we must pay attention to is that this is a square. A square has the length, width, and the height all the same dimensions, right? That's what it takes to be a square. So if each face has an area of 36, I know that it has a length of 6 and a width of 6. That's the only way that the face could have an area of 36 and it be a square. But what else would I know to be true? I would know that the height also has to be 6 because those dimensions have to be the same, the length, the width, and the height for it to be a square. So I know that the length times the width is 36. That it already told me in the question. What is the other dimension that I need to multiply by to get to the volume? I need to multiply by the height, and the height is 6. Well, 36 times 6, however you figure it, whether you do the standard algorithm, whether you do area model, you're going to get to an answer of 216. And it is 216 what? It's 216 centimeters cubed. We report volume with this tiny 3 to show that they are cubed. We report area with the tiny 2 to show that those are square units. That finishes out our Tuesday column.